When we look at question number 11, it says, determine graphically using technology whether the expression secant squared minus cotan squared over cosine appears to be equivalent to cosecant or secant. So I've drawn that graph on this side, and when we take a look at this, this is a secant graph. Okay, so at x equals 1, we have, or x equals 0, we know that the cosine is 1, and so secant is going to be equal to 1 here. And so just mark that point here. This is the point I'm talking about. At x equals 1, cos is equal to 1, so secant, the reciprocal, is also equal to 1. This graph is going to be the same as secant. In part B, it asks for non-permissible values of this identity. Well, the non-permissible values occur when we have a 0 in the denominator. So when I write this equation out, we have cosecant squared, which is 1 over sine squared. And that means that the sine cannot be equal to 0. Cotan is going to be cosine x squared over sine squared. And then we have cosine x in the denominator. So all the denominators cannot be equal to 0, so we know that sine x cannot be equal to 0. That means x cannot equal to, so x cannot be equal to 0, pi, 2 pi, etc. And then cosine x cannot be equal to 0 either. So that means that x cannot be equal to pi over 2, 3 pi over 2, that's going to be 5 pi over 2, etc. Okay? And that's to do with the restriction in the denominator. We can't have sine equal to 0, and we can't have cosine equal to 0. And so for the last part here, we can express this as an identity. We can say that cosecant squared x minus cotan squared x all over cosine x, that's going to be the same as secant x. Okay, and this is now an identity. And later on, we're going to prove this identity.